Hi guys, I'm Doug Peters. I'm the CEO of Peters Heat Treating. Founded the company with my wife 43 years ago. We're here today to take you for a little tour of the shop and talk to you about the processes we do and give you some idea of the capabilities we have. First and foremost in the heat treating business, what we do is we alter the molecular structure to make materials more durable and make them last longer. So for instance, without us, when you pushed your toast down in the morning, the toast would never pop up because there's a little piece of metal in there that is called a spring. And we gave the spring its physical characteristic to be a spring. In other words, without us, you would push it down and that little piece of metal would compress and it's not strong enough to spring back to its memory of shape. So that's basically what we do. And we do that by thermal process. We harden a material, we cool it at a certain rate, and then we temper it to make it tough. Because you see, in the as hardened state, a piece of material is as hard as a piece of glass. And if you've ever taken a piece of glass, if it's not treated and you run it under cold water, when it's hot, it shatters. Well, steel's in a similar condition to that in the as hardened state. So what we do is we'll take a furnace, such as the vacuum furnace here. We'll take a component, such as something like this, and each material has its own specific process temperature set. So we'll harden it, we'll cool it at a certain rate, and then we'll temper it to make it tough. And now we multiply the life of that component sometimes as much as 100 to 1,000 times of what it would be able to do if we just left it as is without heat treating it. We employ 9 vacuum furnaces of Peters Heat Treating. Here in our Meadville plant, the largest furnace that we have is 24 inches high, 24 inches wide, and 36 inches deep with a maximum hearth capacity of 2,000 pounds. Up in the McCain plant, our largest furnace is 47 inches high, 47 inches wide, and 60 inches deep. And we can go up to 5,000 pounds on the hearth in that furnace. Okay, this is our induction station. And the way this thing works is rather interesting. You have a copper coil, and we circulate water through the coil so it doesn't melt. And what happens is, by sending an electric signal through it, you create an electromagnetic field. And within the coil, that electromagnetic field creates a friction. So when you put a piece of steel in, the friction is what heats the material. And so that is how induction works. We use induction for a number of different things. We use it to harden material. We use it to temper material. Tempering is when you take an as hardened structure and you make it tighter so it's more durable. So in other words, as hardened structure might look like this, and it's very brittle. It would be easy to fracture it. But when you temper it, you bring the material grains together to make it very durable. This is black oxide room. Basically, it's a controlled rusting process. By utilizing a known chemical bath at a particular controlled temperature, we can oxidize steel and make it black. So you see, that started out being a shiny piece of steel on the pallet, and now it is black. There's a couple of different uses for black oxide. One is aesthetic. You might have an optical gauge on a machine, and in pie shapes, you'll blacken one pie shape, its neighbor might be left shiny. Then the next one might be blackened. So as that tool indexes around, optically, the machine can see the different colors and then make different things happen. The second reason that you black oxide is for corrosion protection. So for instance, one of the most common things that we blacken or blue in the gun industry is a gun barrel. And you do that for a couple of reasons. Number one, it's anti-reflective. And number two, it's rust preventative. This is our aluminum processing area. We do solution treating, which is the annealing of aluminum, and we do precipitation hardening and aging of aluminum. This is shot peening. And shot peening, or this particular machine, uses a conveyor that drops media, and then there are motorized wheels that sling the media to contact the parts. You can use shot peening to compress the surface to make it more durable, or given a different media in the machine, you can use it for shot blasting. In other words, you can clean the surface of the material. This is the area where we sandblast parts. We have a number of customers that request us to clean oxidation off of parts when we're done with them. And we have two different types of blasters in this room. We have a pressure blaster, and then we have an automated tumble blaster on the other side. And this particular cleaning application can be accomplished with a number of different medias. In our case, we use mostly fine grit aluminum oxides. That's what our customers seem to prefer. These are fluidized beds, and this is used mostly for our tool and die side of the business. It's a bed of uniform grain aluminum oxide, and we purge a gas up through the bottom to take that solid bed of sand and turn it into a liquid. And we can do hardening processes, carburizing processes, annealing processes, carbon nitriding processes. We can nitride out of here. Very flexible piece of equipment. Well, that side of the building is where I started everything. Our original facility on Ray Street here in Meadville was about 6,600 square feet. That facility is about 16,000 when we moved over here. But years and years ago, I started in 2,200 square feet, and then the business grew over there. We put additions on to finally get to 6,600, and then we just couldn't grow anymore over there correctly. And the logistics of being in the same town 2 miles apart, that facilitated that particular building. So that's how that came to be. In 2012, I bought this building over here, and that was to take us to the next generation. Andy and Diana had said yes, they wanted to come home, and I knew that to support our community and all the folks in our company, we were going to have to diversify because the tool and die side of the business was steadily shrinking. And so we had to do something to really get ourselves away from the kinds of things we were used to doing. So in other words, our comfort level had to be interrupted. And basically that's what this side of the building did. Years ago, when we started this business, our customers used to send us the information for heat treating on the back of Nestle Quick labels, on scribbled company stationery, anything they could find to write. So the first thing I knew that I had to do was to standardize the way our customers gave us information, because we were never going to be able to get them to consistently give us the information we needed to excel at our job. So I created this work order. As the customers grew, as they changed, we came up with different things that needed to be on this work order. This work order right here is 1,211,764 job that we have run, okay? These particular pieces of paper, we used to take this part and we would hand draw on this slip what the part looked like. If they were small enough to trace, we would trace them. All of a sudden, we grew enough that the paper was becoming a nuisance. That barcode that you see was at the beginning in 1995. We started developing a proprietary tracking system in this company. And the reason I had to develop it was most of the heat treating industry didn't have them, and they didn't use them. And we were pouring 40,000 orders through here a year, and we needed to be able to keep track of them better, be able to provide our customers more timely information about their order in progress. And so that was facilitated, that grew into our computerized system that takes a photograph of the part. All of the information is populated onto this traveler, and it's done with a barcode wands. We have part numbers that automatically populate a frozen plan that always allows the part to be run the same way. And so this was one of the things that we did years ago to be able to facilitate our growth. And we just went through our second iteration of this, and we're really proud of the system. It really does a great job for us. So an integral quench furnace utilizes two chambers. One is the quench vestibule, and the other is the hot zone. And you have an interior door that operates, and there's a handler that will move the load from the outside vestibule back into the hot zone. Likewise, when it comes time to cool or quench the load, the door will come up, the load will come out, it'll set on this elevator, and then the elevator will plunge into the oil. And that's the way the furnace works. These particular pieces of equipment prevalently are used for neutral hardening, carburizing, carbon nitriding, You can normalize in these furnaces, and you can also anneal, but most of the time we choose other pieces of equipment to do most of our annealing in, such as vacuum furnaces. This is a parts washer, and when the parts come out of these furnaces, they've been dumped in an oil tank, and when they come up, we let them drip off, but we would create a lot of smoke in the plant if you didn't clean the parts before you put them in a tempering furnace. So the parts get transferred into the washer, and it's a combination dunk and spray washer. The oil is then removed from the parts, and the oil is skimmed, and the oil is then captured back here, and it is shipped as a residual waste that can be used for other purposes. This is the atmosphere generator that generates the carbon atmosphere for all three of those integral quench furnaces. Operates at 1900 degrees. Using a nickel-based catalyst, you pass natural gas through that tube, and it creates a carbon content gas that is then pumped over the furnaces. Then the software control on the furnaces, it adds air or nitrogen or whatever to make the gas the right carbon content for processing. This is a row of tempering furnaces, and after the material is hardened and quenched, and it's in that as hardened state, in other words, it is high physical property, we have to temper to make the material tougher so it's not brittle. And we do that here in these tempering furnaces. Some of the things that you can do in here beyond tempering are stress relieving. There's certain materials that are rich in alloy that you can age harden, and we do that in these furnaces. This whole line over here has a capacity of 36 inches wide, 36 inches tall, 48 inches deep, and we can put 3,500-pound loads in every one of these furnaces on the integral quench side of the shop. If I look at both shops, our maximum capacity for nitriding, for instance, we can run 20,000-pound loads, and we can run up to 144 inches long by about 5.5 feet in diameter. We can also stress relieve to that same specification. We can age harden to that same specification. So those furnaces are large, and that we can do all of those processes in those big nitriding furnaces in our McCain plant. Our services are many, but our services are only as good as the information the customer provides. We invite all of our customers to come and visit. We challenge each and every day everybody in our buildings to become better at what we do, and we will always try and do a better job than we did yesterday. I can tell you that the effort that you will get, I guarantee you, will be the best we have to offer.